Hey everybody, welcome back. Today I'm joined by my daughter.
Hello! In today's episode, we will read an integer from the keyboard and reverse it.
That's it, let's go. Alright, let's talk a bit about the problem. How shall we do this?
So we need to build it up. So, if you do like something, I don't know, just random number, modulo 10, it gives you the last one.
The last digit, yeah.
As you can see, also works if I do that. So it is the last one, we have tested it out.
Yeah.
And what we can do is then do it times 10, then it's 70, and do it again, and then do that, and then this goes away, and it's
How do you make the 7 go away?
divide by 10.
Exactly.
Because then
divide
it
by
goes
10.
to comma, but then the comma doesn't go in because it's an integer.
Correct. Disappears because the division by integers, so the comma disappears. What's after the comma? And then you just repeat the whole thing.
Just repeat it, and we just add them up until it's the complete opposite.
So just to recap the algorithm, you want to go ahead?
We are going to read an integer, then we're going to do modulo 10, which gives us the last number, and then we're going to put it into a new integer, then do the original integer divide by 10, so the last number that we just took goes away.
Yeah.
Then we do the second integer that has the last number,
the one we're building,
times 10, then it adds a 0, and then we do the same thing, and then we add up then we add it up to that, so it's
we add up the modulo
Yeah.
to that number.
Yeah.
And that
So
means
then
we build up the new number, only this time will be in reverse.
Yes.
Okay, seems simple enough. Do you want to code it?
Yes.
Okay, let's
So
go.
first you need to read the integer. I am in no mood to actually do it, so I'm just going to copy it.
You have no... You're in no mood to read an integer, so you're just going to copy.
Yes.
Okay, fair enough.
I mean, if you're smart, you're lazy, so... Oh, wait, I don't have to get...
Okay, let's talk now what we have here.
We have a number that we read from the keyboard.
Exactly. So this is the number we want to reverse.
Yes.
Okay, so go ahead and start the reversing algorithm.
So n. We need to make a loop so while n does not equal 0,
okay,
it goes on.
Yeah.
So then we declare an int reverse equals 0, and we can delete that. No, wait, other way around. Okay, so then reverse equals, and then we do n divided by 10, and reverse. Oh, wait. And reverse. I have learned. And reverse times 10. And we're done.
Test it.
Oh god, okay, and I didn't have.
And nothing comes out.
Because I forgot to do that. Reverse.
Just do 1, 2, 3. Can you make that window a bit bigger so we can see the numbers? Okay, so what's going on? What's wrong?
I don't know.
Then
so
debug it.
Let's debug it. Oh, I have to put the thingy.
Breakpoint and debug.
Okay, so 1, 2, 3. That's true. That reverse becomes 3. And that becomes 12. That becomes 30. That's still true. That becomes 32. That becomes 1. Now that becomes 320. Now that becomes 0. And that becomes 720. That becomes 0.
And here the algorithm should stop. But you're doing the times 10.
Oh.
So think about it.
Oh, wait, I gotta put this forward.
Imagine you jump into the loop and you have already built up the number, the reverse. Let's say you built up 12 or 32, because you're reversing it. You build up 32, and you jump into the loop and you want to take the last digit from n, which is 1, and add it to that 32. So what do you need to do first? Because your solution should be 321, 321.
Yeah.
So what do you need to do first thing in the loop?
First we need to do this. So now you gotta switch these two.
But if you do that first, it will be 32 plus 1, it will be 33. You don't want that. You want 32, and you want to add the 1 at the end.
Yeah.
As an int.
So you do this first.
Yes. So you do 32 times 10 first, which makes it 320. Then you add the remainder, the modulo.
But 0 times 10 is still 0.
Which is exactly what we want.
Okay.
So let's see how this works.
1, 2, 3, 4, 5. 5, 4, 3, 2, 1.
Can you debug it now? Let's go line by line to see how actually it works, how it builds up the reverse.
Yeah, I can make that bigger. 1, 2, 3. Probably not gonna help, but okay. So that's true. Then we do that times 10, which is still
So whatever
0.
was there in reverse, it was nothing. Times 10 is still nothing. Then you add up now the remainder,
now
which is
3.
3.
Now it's turned to 12.
Now you destroy the big number, the initial number. You just remove the 3. So you're left with 12.
And now it's times 10, which is 30. Now it's 32. Now it's 1.
You remove the 2 from the 12. You left with 1. Now you need to add that 1 to the reverse. So reverse is 32, so you need to first multiply by 10. Plus
now plus 1.
1.
And then that's 0. And then that becomes false.
So you're exiting the loop, and the reverse is 3 to 1.
And then you exit.
Okay.
That it?
That's it. Does it make sense?
Yeah.
Okay. Let's think about some funny cases, corner cases, something that can go wrong. If it goes wrong, when would it go wrong? What do you think?
Do a minus number.
Exactly.
Ooh, I want to try that. Let's see
what happens if you have a minus, a negative?
Wait, no. Minus 1, 2, 3. I don't think it'll work. I think we'll just do 320. And it worked.
Okay, let's debug it now quickly to see how it works line by line.
I do not think that's going to work. Okay. Is it debugging? Okay, yes it is. Now minus 1, 2, 3. Oh, let's do minus 321. It goes back like that.
Okay.
Okay.
So reverse is 0, n is not 0.
Then times 10,
It's
still 0.
Still 0. Now we do modulo. Minus 3 to 1, modulo 10 will be
1.
minus 1. Minus 1.
Now it's minus 1.
So reverse is minus 1. Is 0 minus 1 minus 1. And
now that is 32.
Minus 32, yeah.
Sorry.
And it's not 0. Reverse is minus 1 times 10. It's going to be minus 10.
And then it's going to be
Modulo minus 32, modulo 10 will be minus 2.
Minus 12.
Yeah.
Then the 3. Now it's minus 123.
Good. You know, funny, when you said initially here in the while loop, while n is not 0, I was almost going to say while n is greater than 0, then do this. And when it becomes 0, then exit, which would have not worked in this case.
So I thought ahead
so
without knowing.
So you thought ahead without knowing. Okay, good job. Simple algorithm.
Are there any more corner cases?
Any more corner cases? Let's see. Well, if n is an integer, then basically it cannot be anything else. It cannot be a string, it cannot be a
Yeah.
char, it cannot be a float, a double, because it has to be an integer.
Yeah. And it can't be above the integer limit, whatever that is.
It cannot be above the limit, yeah.
But they wouldn't. But
So basically, above the maximum allowed int or the minimum allowed int, it's still an integer. So yeah, I don't think there's other cases. Okay, everybody, that's all I have for today. Thanks for watching. And if you think this content is interesting, then you know what to do. Thanks.
leave a like.
See you in the next one. Bye bye.
See ya.